Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of redox reactions. What is a redox reaction? Well, it's a single replacement reaction in which we basically have a transfer of one element into a compound and the other element out of a compound. So in this case, silver will be in solution with some sort of anion. And when the single replacement reaction takes place, I'll talk about that here in a second, we actually see the silver coming out of the solution, becoming a solid and being displaced by the calcium. Calcium comes in and goes in the solution, whereas the silver precipitates out, becomes a solid. Okay. We'll discuss how this is possible, how to predict whether or not this will occur, and what the concepts behind a redox reaction. First things first, what is a redox reaction? A redox reaction is a shorthand notation or term for oxidation reduction reactions, and basically these are a general class of reactions that involve a transfer of electrons from one substance to another. So oxidation and reduction always must occur together. Let's look at each individual process. Reduction is the process of gaining electrons. So if we're looking at this is the half reaction of the redox reaction I showed you earlier. Okay, so you can see silver gained electrons. We're just looking at the silver. So this silver gained electrons, so it undergoes reduction. Now the reducing agent is the thing that supplied this electron for the silver to accept. In this case, it's the calcium. So when we're looking at a redox reaction, a quick way to determine the reducing agent is look for the one without a charge, or the one that's solid. Some people use the opposite rule, thinking in the form of agents, double agents do the opposite of what the actual process does. So if reduction is the gain of electrons, a reducing agent must lose electrons. It does the opposite. So what's the thing that loses electrons here? The calcium. All right. Now let's look at oxidation. Oxidation is the loss of electrons. And here's the half reaction for oxidation. You can see this calcium lost electrons. So for oxidation, the electrons are always on the right side. For reduction, the electrons are always on the left side. Once we get these half reactions, what we will do is multiply both equations, or one equation or no equations, by a number, just to make their electrons the same on either side, so that when you add them, you end up with the electrons canceling out. And I'll show you that when we do an example. In other words, we can look at it as follows. The reducing agent is actually being oxidized because it donates the electrons so that reduction can take place. Let me say that again. The reducing agent, in this case, is going to be the solid, right? Because it donates electrons. Why is this a reducing agent? Because these two electrons is what allows reduction to take place, right? These two electrons go and they combine with the silver. Right? You're going to have to balance the equation, but yes. And the oxidizing agent is being reduced because it accepts the electrons, right? So this is the oxidizing agent. because it's going to accept an electron. So when we're looking at a redox reaction, the first things you should be able to tell right away are the oxidizing agent, because it has a charge and will accept the electrons. Okay. And the reducing agent, which donates the electrons so that silver can accept them. So again, solid is going to be reducing, charge, cation, charge plus charge is going to be oxidizing agent. I hope I've clarified any doubts that you might have over oxidation reduction reactions, collectively termed redox reactions. Make sure you can identify easily the reducing agent, the oxidizing agent, and be able to go from a whole reaction to the half reactions of reduction and oxidation and put the electrons in the correct place. You need to be able to do all those things before you can start talking about the single replacement reactions that occur using an activity series. That will be the second half to this redox reaction video, so make sure you check out that concept video as well, and there will be several example videos. So practice, practice, practice. Thank you and have a nice day.